Okay, I'm working on Bi-toroidal transformer, BiTT, kind of a thing Karl Heinz invention. And here's the one I got so far. The primary is in the middle there, and then it has a secondary to the left and a secondary to the right. And I'm doing it a little bit different. And then I'm putting extra winds over the coil. And these I pulled back. I'm using green florist wire. It's soft steel, very magnetic, and it's got an enamel coating on it, so it kind of insulates it like laminates in it. So see this one here? See, I put extra core material going on the outside of the coil, laid on top of it. And that one's how it is on that side. This one I pulled back because I broke some wires and I had to resolder them. So I have that core material of the florist wire pulled back out of the way. So what'll happen is it'll be thicker along here, and not only the path of, call it the shunt bar, is there, but also it'll be having more of it, picking it up on the sides of the coils, secondaries, and I could go even more and completely encase the whole thing. And I might do that later. That's a little confusing. Here's another one I got. It's pretty ugly. So just to explain really quick, probably a lot of you know about this already. Here's the primary. You send power in here, AC. And it'll kind of split itself and go around here and around here, the flux. So when you power this, you'll be inducing power in here and here at the same time. And now the idea is, like on AC, when it switches from the positive to the negative, all of a sudden you'll get this back EMF. And so the back EMF, like let's say this is energized this way, the back EMF, instead of going back and kicking into the primary, like let's say the initial flow goes this way, the back EMF upon switch off or changing your phase direction will knock that back EMF here and you'll get reflection. So when you take power out of the secondary, you make a lot extra draw in the primary. So it's not anything great, but you can kick down voltage or you kick up voltage. But this section here, you call the shunt bar, and that will transfer the back EMF energy over to the opposite secondary, reinforcing it. So instead of it going back causing extra draw, it goes back and actually makes more power. So it's pretty cool. This should be thicker. Most people use three-phase transformers for this, and I'm using this florist wire. And you can get it at art supply stores. Here's like about 22 gauge. It's a little bit thinner. Then I have these pretty thick ones, like, I don't know, 16 gauge or something. So that's what I'm going to be making these out of. I made a few. Here's a little weenie one. And there's the primary in the middle. And two secondaries on the outside. Here's one I made out of ferrite rings. I don't know how this one's going to work. Seems like the crossover isn't maybe so good, but maybe it'll work fine. I have tested these. I built these about over a year ago, and I didn't see anything great, but there's some people like Tim Tron and Thane Karl Heinz too, who get like 3 times over unity, 6 times over unity with these things. So I'm coming back to it, seeing if I can do something good. I have a variac here, so I can find a good voltage input. Like this one will get hot like about 40, 45 volts or so. It'll start getting kind of hot in the primary. So, anyways, hold on a sec. Okay, I have these really nice core material. It's like powdered iron type formula. And I ordered these quite a while ago, a few years ago. I made some Rene chargers. I have these bigger ones, 1 inch by 1 inch, and then little small ones. And these were supposed to be good for around 60 hertz, and they gave the specs what you want. I got a big bag of them. So I was thinking about making some Bi-toroidal coils out of these, but right now I'm doing florist wire. Hold on. Okay, here's my test bench. Look at all these oil-filled AC caps I got, all different sizes. I got another whole mess of them. When I did rotoverters a lot, which is really great thing to be experimenting with. I got a lot of those. So you want a lot of different sizes. So anyways, I got those. Got my meters, got my variac. I'm using these resistors here for the resistive load. I also made this thing, which is pretty cool. Variable resistor, so you can put, like, you know, between here and here, it goes like about, here's about 5 ohms, 10 ohms, about 25 ohms. So this is 0 to 25 variable resistor thing. It's bare steel wire. And so you can zero in on the very best resistance. Could make one really a lot longer and have it like 0 to 100 ohms or so. That's only 0 to 25. So here's what I'm doing. Now I'm going to show you a 3-phase AC transformer. I got a couple of them in here. Now normally what people do, you take a 3-phase AC transformer and you chop up a microwave oven. See the laminate steels? And you make a shunt bar like this thick out of laminate steel. Have it go up a little bit and then across and then down. So you make it like this. Here, over to there, and to there, and you have a nice magnetic connection, latch, whatever you call it, both above and below. So you put one above it and below it, and that'll cause the back EMF forces Instead of going back into the primary, it shoots back over to the secondary. So it not only makes the draw not go up, but it also reinforces, maybe coheres what you're making in this secondary with this secondary, and what you're making in this secondary cohering with this secondary. Okay, I have an improvement I want to throw out there that I want to try pretty soon. Hold on a sec, I'll get this piece of paper. Okay, so here's the basic bi-toroidal transformer. And then what you do is you make a shunt bar that goes up here like this and across like that, you know. Okay, so the shunt bar will be added on to the basic three-phase transformer, 1A, B, and C, okay. Coil around here, coil around here, coil around here. And you do the same thing on the bottom as on the top, okay. Now look at the, let's say the coil is wound around the primary and you hit it with some AC, and the first phase makes it go north here and south this, down here. So that's the polarity. So you see these arrows, it flows around like this, okay? And it flows around like this. It kind of splits and goes both ways. It's going to be important to make this all the same, you know, same distance, same everything, so that it'll split evenly. Okay, so you got a flux going around this way, and you got a flux going around this way, okay? Now let's say you wanted to figure out what the polarity is. Okay, you know this is north on top. Now this has to be south here and north here, this block of the rectangle, because it's going to like latch into the north and south here. Okay, it has to be like that. And when it comes down this way, it's going to have to be south-north here, because the north and the south will latch up. When it goes this way, it's going to have to be, this bottom one is going to be like this, okay? So see that? And it's the same thing on the other side. It's going to go south-north on top, south-north here, south-north here, and then it's going to latch into here. See the south? Here's the two norths. So that's, if these were magnets and you put them there, that's the way they would all lock together. And this is the way the polarity is going to go on the secondaries. See that? It's going to be a south on top and a north on the bottom. South on top, north on the bottom. Okay, so that's the way it is. I don't think there's any argument about that. So now the way it works, and you see some explanations of it, is when the phase changes polarity, or if you're doing DC in there and you turn it off and the back EMF or whatever you call it comes shooting backwards, the inherent backwards force, you don't want it to go into the primary. You want it to go up on this shunt bar, okay, and reinforce the opposite one. Now, there's a problem I see. If you read about this, they say what happens, okay, so this is south and this is south. When the shunt bar comes up, when the switch turns off or it changes phase, the back EMF is going to be going this direction, and the back EMF is going to be going this direction, and they collide. There's a collision course right in the middle because they're opposite. Now, it seems to me you don't want that. That's okay. I guess it works, you know. some of it gets through and comes back, some of it gets through and comes back. And maybe how these really work well is you have absolutely perfectly matched timing and magnetic force, so that when these collide, it's a bucking magnetic field and it shoots backwards. Could be, but I think it kind of, half of it sneaks through and half of it sneaks through. If one's a little bit more dominant than the other, it's going to overwhelm it and just make it all go one way, as far as I know. So I have all these individual strands of florist wire, and maybe that'll make it work better, and I think you need to have laminates. But here's what I'm getting at. Try to hold the camera steady. Seems to me a shunt bar, rather than having it be a bucking field here where it collides, because this is south here and south here, and they're both going to shoot back of opposite polarity for that as it jumps over the primary. And you know, that's the whole idea, is you bypass the primary and you bring it over to the secondary. Now what about you bring this out and you don't have it go this way, you have it go across and have it come in here, down here. Now it's going to really reinforce the secondary. And then do the same thing, have this one come up here, go underneath, come in here. Because, okay, let's say this is south and south, okay? So this is going to be a north, north. And if you bring it over here, it's going to really reinforce. It's going to be north down here. Seems like that's what you want to do, is have the shunt bar go up and over, just straight across if you want. And then shove it in right here. Bring this one straight across. This one will go on top. This one, bring that down below, and then shove it in right here. Now, there won't be any bucking thing going on. It'll be a real reinforcement of the secondary. It's going to be in the flow of the secondary. And there will be no bucking. So that's what I'm going to try, because I have this florist wire, so I can make something like this pretty easy. Have a big, thick mass of florist wire that goes across, so it'll be a really good magnetic path to follow. So I'm going to try that. And if any of you have comments, write it in the comment section. This might be a really good way to do it. Meanwhile, I'm going to keep going with what I got, see if I get some good stuff out of this. I did some testing and I didn't see anything too great. I would see the draw go down when I power the secondaries, but I didn't see anything over unity like the input of, I was using these little 300 milliamp 12 volt transformer coming off the grid, and I was powering this with that, and I could feel it like, you know, going. Could feel the hum of the primary, and it was inducing into the secondaries pretty good. And I did all the testing on the secondaries. I put them in series. This is what Tim Tron did, and when he used a 10 UF cap across the secondaries in series. That was like the cap you want to use. And so I did some testing, and a 20 UF cap for me, I would be getting 12 volts out of the secondaries. I put in 12 here, and I also got about the same out of here. But when I put a 20 UF cap across, I'd get 36 volts, and that was pretty good. So and then I would put resistors across it, and I'm just working in AC. I'm not putting it into a full wave bridge and doing DC. I'm just doing AC right now. And when I put a resistor across, the power going into the capacitor secondary output, it would knock the voltage down. And if I used a heavy resistor, it would knock it down quite a bit, like about a 20 ohm. If I used like 100, I did a bunch of resistor tests. 150 ohms was the best. And this was before I put this wire here. And this was before I was using a variac. So I didn't see anything too great, but I think I got to keep working on it. Zero in on the best voltage input, best resistance value, best capacitor size. And then I found I broke some wires. I actually cut into them accidentally, and I was only getting this going into one secondary, and it was like, what's going on? And oh, finally figured out the wires were cut. So I just repaired those. I'm gonna show this real quick. So when I wound these coils, I did them quad filers. There's 4 wires together because it makes it a lot easier to wind if you have like 4 of these together, and then you can wrap them around, you know. You can do it pretty quick. And then I hook them all in series. So I have 4 bare wires here, and then 4 bare wires on the out. This is what I just repaired. Not bare wires, but magnet wire, and I scraped the insulation on the tips. So that's what I'm going to do next, is hook these in series. They call it series aiding, so for the highest impedance. So eventually I'll have just 1 wire out, 1 wire in, and then the other 3 wires will be hooked up. They'll be anyways. So you can go like parallel and change the impedance, but I'm just doing this high impedance right now. So it becomes like a single wire here, but it's aiding, series aiding. These are about, I'd say 24 gauge wire. It's not quite 22. So that's where I'm going with this. And I'm kind of itching to try this idea right here, with it going from here to here rather than going from here to here. Seems like a lot more logical thing to do. So anyways, okay, sorry about the long video, 24 minutes, sorry. Thanks for watching. Leave some comments if you want. Okay, thanks.